Our next rule for dealing with exponential expressions is called the negative exponent rule. This rule you did not pick up when you first picked up exponentiation in elementary school. So we'll spend a little more time, although the presentation will be fairly short. The negative exponent rule reads like this. If b is any real number other than 0 and n is a natural number, then b to the negative n equals 1 over b to the positive n. Also, 1 over b to the negative n equals b to the positive n. Now that sounds and looks very confusing, but it's actually quite a simple concept. Here, do not let your base be 0. Why is that? That is because it shows up in the denominator. Whether you had it initially or after you finished, it ends in the denominator, and thou shalt not divide by 0. So do not let b be 0. And it also specifies a natural number, even though this can be extended into any number. But for right now, this is where you are in your learning. Now, b to the negative n. You've got a base raised to a negative power. Notice that in the answer, the b moves from the numerator into the denominator, and the power becomes positive. It's the same numerical power, but it becomes positive instead of negative. And if the b you started out with the negative exponent was in the denominator, he moved to the numerator, and the exponent became positive. So when you boil this down to very simply put language, if you have a base to a negative exponent, change the position of that base, numerator to denominator or denominator to numerator, and then make the exponent positive. Okay, let's take a look at a couple of sample problems here. Use negative exponent rule to write 4x to the negative 3y squared with only positive exponents. Okay, first recognize that you have a fraction. It's just over the understood 1. So 4 is in the numerator. No negative exponent. He's fine where he is. Leave him alone. X, however, has a negative exponent, so I'm going to drop him down to the denominator and change negative 3 to positive 3. Y has a positive exponent, so he's going to stay in the numerator and keep his positive exponent. So 4y squared over x cubed is my final answer. Not nearly as bad as it looked at the beginning. Okay, let's try the next one. Use negative exponent rule to write that ugly thing with only positive exponents. Again, I've got a fraction. 3 is in the numerator. There's no negative exponent on him, so I'm leaving him alone. I come across y to the negative 5th next. Well, that negative 5 exponent I want to get rid of. So I'm going to drop x down to the denominator and change negative 5 to positive 5. Back up here, y to the 2nd power. Looks fine. Got a positive exponent, so I'm going to leave y to the 2nd power up top. But when I get down to the denominator, z is to the negative 3rd power. So I'm going to move z from the denominator to the numerator, change its position, and make the exponent positive. So to the positive 3. And that's my final answer. All right, I hope you're getting this, but we're going to look at 2 more examples on the next page just to make sure we've got it. Okay, so 2/3 x to the 8th, y to the negative 3rd. Don't do anything weird with this, guys. You've got a fraction. 2 is in the numerator, 3 is in the denominator. Leave it like that. Please don't write 2/3 in the numerator because you're not allowed to have a fraction inside a fraction. Okay, but then x is positive 8, and he's in the numerator, so he's going to stay. Y's exponent is negative 3. He's in the numerator. These two guys are still over 1. So he's in the numerator, so to change that, I'm going to drop him down to the denominator and change -3 to +3 and call that my final answer. Okay? All right, one final problem that I threw in because I had some students last year who missed this. That 4/6, yes, I will grant you that 4 is good in the numerator and 6 is good in the denominator. But guys, you can reduce 4/6. You've been doing that since 3rd grade. Please keep doing that. You never get to change it. So I'm going to reduce the 4/6 to 2/3 by taking a 2 out of both, in case you're curious. All right, then I read on. Behind the 4 in the numerator, I see x to the +4. Since his exponent's positive, he's going to stay where he is and keep it positive. Then I see y to the -2. Since that exponent is negative, I'm going to move it to the denominator and make the exponent positive. Then the only number I haven't dealt with is z to the -2. And since he's negative in the denominator, I'm going to move him to the numerator and make his exponent positive. And therein lies my final answer. I hope you're understanding a little bit better. Please practice these until you get very fluent with them. They will make a huge difference by the end of the semester. Good luck.